In this lab, we're going to add support for loading text into our word processor, as well as support for saving what we've written. An easy way to implement this feature is to utilize the static file class. Remember that since it is a static class, we do not have to create an instance of it, so we can just access its members directly. The two methods we will utilize from it are the read all text and write all text methods, as seen here. Both take the full path of the file you are reading or writing, which includes the file name. The write method takes an additional string parameter that's the content that you want to write to the file. Unlike some other methods of opening files in C#, read all opens and closes the file, so you don't have to do that manually. The write all method works in a very similar way, but will also overwrite the contents of the given file if it already exists. Working with files is one of the common tasks that we as programmers have little control over. There's a lot of things that can happen, and when opening a file, that may cause exceptions to be thrown, even if your code is perfectly fine. The most common issues include accessing a file that's been locked or been used by another program. You've probably encountered this all the time when trying to upload a file or attach one that is still open, especially when attaching things like homework to an email that you're still working on. Some files are read-only and cannot be opened into write mode in C# or other programming languages. And in rare cases, a file may get moved or become unavailable when it's been selected. And in extreme cases, that would be maybe even a hard drive that got corrupted, or even a flash drive that got removed. An easy way to actually simulate this error, though, is to open a file or save a file, put a breakpoint in on the dialog box before you actually start moving forward, and then just rename the file or move the file to a different directory. The try catch statement, which you've probably already seen before in programming languages like Java or even Python. The try catch statement allows us to handle these exceptions so the user doesn't accidentally crash our application. Now, let's take a look at an example here of some exception handling. This is probably something that you're most familiar with, at least this formula here. The code that might cause an exception is contained within the try block. If an exception is thrown in this block, the code in that block immediately stops executing, so it won't continue on fully executing all the code in the try block. It will stop as soon as it is encountered the exception. This operates just like what you would see with a break statement inside of a while loop. But after the exception is thrown, the catch clause is triggered. It's important to note that you should be careful what code you actually put inside of the catch block, because if you put anything in the catch block that might throw an exception, it won't be caught unless you wrap that code in a try catch clause as well. Now, a try catch statement may also include a final clause. That is, generally speaking, always executed after the try block has finished or the catch block has finished handling the exception. We won't need to use the final clause in today's lab, but it's definitely something that is very useful in practice. But our try catch statement here is pretty generic. It will catch pretty much any exception that is thrown, right? But it's not something that we generally want to use in practice, because with this, we can only provide very general feedback to the user to what's actually happened. And for most of our uses, this is going to, like I said, work perfectly fine for labs and what we do in 300. But in practice, it's best to have more specific error handling. Let's take a look at an example. We can do that by adding more catch blocks. These additional catches must be in order of generality from most specific to least specific. All exceptions are child classes or inherit from the exception class, which is the most generic form of exception that we can have. But in this way, we can provide a better experience for users and still handle errors that we don't expect to happen. Like here, we may know of the file not found exception or expect that they are trying to open a file that doesn't exist. Or maybe there was an error in handling the file, like maybe the file was corrupted or the file, something bad happened to the file while it was trying to open in any way, shape, or form. That would be, generally speaking, the IO exception. But what if the exception is neither of those? We still want to have the generic catch exception because we can't take into account all possible cases in programming. Well, at least in a lot of cases, because there's just so many options out there that may actually happen, or bad things that may actually happen. So it's pretty good practice to have a general catch at the end of your try catch clause, and then before it, put all the more specific exceptions that you know of or that you want to provide a message for your users for. And a few additional quick notes about file IO or in general file paths in C#. This is a pretty tricky thing to get right, especially if you find yourself trying to hard code a particular path. Most of the time in what we're actually programming here in CIS 300, we're going to primarily be loading all of our files through the open file dialog box or the save file dialog box. But on occasion, we may actually have to hard code or want to hard code a path name. The first example that I have here doesn't really work very well because I'm using the /. This slash is the escape character, so it's going to interpret the following character after it in a unique way, so we can't typically use that. This is the slash that you get typically from copying and pasting or copying a file path from the Windows File Explorer. The second example that I have here uses the escape sequence, so we do //. So we force C# to interpret that slash as a normal character, not as the escape character. This works pretty well, but personally, I find it a bit of a pain to actually go through and add all those slashes back in, even though it's not that much work. The last example is my personally preferred way of interpreting file paths in C#. If you preface your string with the @ symbol, it'll actually force C# to just interpret all the contents of that string as a string. The only downside to this is if you use the @ symbol, but you still need to use an escape character inside of your string itself, it won't work, regardless of what the escape character actually will be. And that's pretty much our basic file IO. So we're going to be using the static file class to open and save our text for our word processing application. In the future labs, we're actually going to start looking at more complicated ways of opening files, particularly for files that are more that aren't raw text, or maybe thousands of lines of text long.